Today we are going to see test of significance for correlation coefficient. The actual magnitude of covariance of x comma y does not have much meaning without knowledge of variance of x comma y. When we wish to compare the covariability of two distributions, suppose covariance of x comma y is equal to 1 for one probability distribution and covariance of x comma y is equal to some other number for another probability distribution. We cannot now say that the tendency of x and y to vary together is greater than in the later case than in the former, since x and y themselves might vary greater in the later case than in the former case, which will increase the numerical value of covariance of x comma y. Hence, we introduce another concept known as correlation, which gives a measure of covariability taking into account of the variance of x and y. Here, we want to test whether the population correlation coefficients is 0 or population with correlation coefficients. Population coefficient is not correlated. So here, three types of testers. Type 1, suppose a sample of n pair of observation xi comma yi taken from a population with the two characters x and y. Now we want to test whether the population coefficient is 0. That means we want to test hypothesis, null hypothesis, correlation coefficient equals 0 against h1, this one is not equal to 0, where rho is the population correlation coefficient, let R be a small observed correlation in the sample, then it has been shown that z equal to the square root of n divided by square root of 1 minus r squared, has the normal distribution n of 0, 1 mu comma sigma. If n is small, then t equal to modulus of r square root of n minus 2 by square root of 1 minus r squared has a t distribution with n minus 2 degrees of freedom. Example, a sample of 64 pair of observations showed a correlation coefficient of 0.2 can we conclude that the samples belongs to an uncorrelated population. Solution. Null hypothesis, first fix null hypothesis, population correlation coefficient is equal to 0. The alternative hypothesis is not equal to 0. But z equal to the test, z equal to modulus of r into square root of n divided by square root of 1 minus r squared. That is equal to r is given, r is equal to 0.2, r is equal to 0.2 and n is equal to 64. So 0.2 into square root of 64 by square root of 1 minus 0.2 the whole square. That is equal to 0.2 into 8 divided by square root of 1 minus 0.2 the whole square. That value is 0.9797. So 1.63. So z value is 1.63. If the calculated value z is less than 1.96, then H0 is accepted at 5% level of significance, and if it is greater than 1.96, it is rejected at 5% level. According to our problem, Z value is equal to 1.63 is less than 1.96. 1.63 is less than 1.96. So the null hypothesis is accepted. That means the sample belongs to an uncorrelated population. Then type 2, suppose a sample of n pairs of observations xi, yi be taken from a correlated population with respect to two characters x and y. Let rho be the correlation coefficient from the population and R be the sample correlation coefficient. We want to test whether there is a significant difference between rho and R. Correlation coefficient from the population and the correlation coefficient from the sample. Here H naught rho is equal to R. Alternative hypothesis, rho is not equal to R. But in this case, if Z equal to 1 by 2 log base E 1 plus R by 1 minus R and Z not equal to 1 by 2 log E 1 plus rho 1 minus rho, then Z is approximately normally distributed with the distribution n of Z naught comma 1 by n minus 3. That is Z equal to, therefore Z equal to modulus of Z minus Z naught by square root of 1 by n minus 3 is n of 0 comma 1. Same, if the calculated value of Z is less than 1.96, then H naught is accepted. At 5% level, and if it is greater than 1.96, it is rejected at 5% level. Example, the correlation coefficient in a sample size 103 was 0.7. Test the hypothesis that the correlation coefficient with population is 0.6. But the last problem, a sample of n pair of observations showed a correlation coefficient is 0.2. Can we conclude that sample belongs to uncorrelated population? But this question, the correlation coefficient, the sample size was some number. Test the hypothesis that the correlation coefficient with the population. So solution. Here rho is equal to population correlation is 0.6 and sample correlation is 0.7. N is equal to 103. N is equal to 103. So Z equal to 1 by 2 log base E 1 plus R by 1 minus R. Note that log base E n is equal to log base 10n into log base E 10. We can write this. According to this one, 1 by 2 into log base E 10 into log n. N is 1 plus R by 1 minus R base 10. So that is equal to 1 by 2 log 10 base E, that is equal to 0.302585. So log, this is 2.302585 into log base 10, 1 plus 0.6 by 1 minus 0.6. So this value equal to 1.1513 into log base 10, 1.6, 1.06, that is 1.6 divided by 0.4, that is equal to 1.1513 into log 4 base 10, that is equal to 1.1513 into 0.6020, that value is 0.6931. Similarly, Z naught equal to 1 by 2 log of 1 plus rho 1 minus rho base E. So just like this previous procedure, 1 by 2 into log of 10 base E into log of 10 1 plus rho by 1 minus rho. So this value is 1.1513 into log 10 1 plus 0.7 divided by 1 minus 0.7, that is equal to 1.1513 into log base 10 1.7 by 0.3, that is equal to 1.1513 into log of 1.7 minus log of 0.3 base 10, that is equal to 1.1513 we can write 0.2304 minus log 0.3 minus of, so minus of minus plus 0.5229, that is equal to 0.8673. So Z equal to modulus of Z minus Z naught by square root of 1 by n minus 3, that is equal to Z 0.8673 minus 0.6931 divided by square root of 1 by n. N is 103 minus 3. So square root of 100. So that value is loss of 0.8673 minus 0.6931 into 10. Reciprocal value. 100 means square root of 110. So actually this value is 1.742. So the table value of Z at 5% level is 1.96. Since the calculated value of Z is less than the table value of Z, so null hypothesis is accepted. That means the population correlation coefficient is 0.6. Type 3, test of significance. For the difference between two sample coefficients. Let R1 and R2 be the sample coefficient and N1, N2 be the sample size. We want to test whether they belongs to a population with the correlation coefficient rho. Here H0 is the sample belongs to the population with the correlation coefficient row. The alternative hypothesis, the population coefficient is not the population correlation coefficients. Consider the transformation Z1 equal to 1 by 2 log base E 1 plus R1 by 1 minus R1. Z2 equal to 1 by 2 log base E 1 plus R2 by 1 minus R2. Then Z1 minus Z2 is approximately n of 0, 1 by n1 minus 3 plus 1 by n2 minus 3. Then Z equal to modulus of Z1 minus Z2 by square root of 1 by n1 minus 3 plus 1 by n2 minus 3 is n of 0, 1 mu sigma. If the calculated value of Z is less than 1.96, then null hypothesis is accepted. If not, it is rejected. Example, two independent sample have 39 and 52 pairs of values with correlation coefficients 0.6 and 0.7 respectively. Are these values consistent with the hypothesis that both the samples have come from the same population, same sample population. Solution. In this problem, R1 given, R1 equal to 0.6, R2 equal to 0.7 given, N1 equal to 39 and N2 equal to 52. So null hypothesis, these two are equal. The sample, both the sample have come from the sample population. The alternative hypothesis is not. So just find Z1, 1 by 2 log base E 1 plus R1 by 1 minus R2. So already we know that this value is 1.1513 into log 4. that is equal to 1.1513 base 10, 0.6020, that is equal to 0.6931. Z2 1 by 2 log base E 1 plus R2 by 1 minus R2. This value already we know that 1.1513 into log 1 plus 0.7 by 1 minus 0.7, that is equal to 0.8673. R1 is R1. R1 is equal to 0.6. So already we know that R1 equal to 0.6. So Z equal to modulus of Z1 minus Z2 by square root of 1 by N1 minus 3 plus 1 by N2 minus 3. That is equal to modulus of 0.6931 minus 0.8673 the whole divided by square root of 1 by 36 plus 1 by 49. So this value is equal to 0.1742 divided by, use calculator, 1 by 36, 0.0277 plus 0.0204, that is equal to 0.1742 by square root of 0.0481, that is 0.7943. Conclusion: since the calculated value of Z is less than the table value of Z at 5% level of significance, so hypothesis is accepted. Therefore the sample have come from the same population. Another example, a correlation coefficient 0.7 is observed from a sample of 28 pairs of observations. Obtain 95% confidence for population correlation coefficient. A correlation coefficient given is observed from the sample of 28 pairs of the observations. Obtain 95% confidence interval for population. So at 95% level of confidence, table value of Z is 1.96. For 95% confidence of interval n is equal to 28. So z equal to 1 by 2 log base e 1 plus r by 1 minus r. So this one 1 by 2 log 10 base e into log 10 1 plus r by 1 minus r. So this value is equal to 1.1513 into log of 1.7 divided by 0.3 because r is equal to 0.7. So this value is equal to 0.87. But modulus of z minus z naught by square root of 1 by n minus 3 is less than 1.96 because 95% level of confidence value of z is 1.96. So definitely modulus of this value is less than 1.96. That is equal to 0.95. That is equal to 0.95. So P of z minus 1.96 into 1 by square root of n minus 3, which is less than z naught, which is less than z plus 1.96 into 1 by square root of n minus 3, that value is 0.95. So probability of P of 0.87 minus 1.96 by square root of n minus 3, that is 5, less than z naught, which is less than 0.87 plus 1.96 by 5 is equal to 0.95. So probability of 0.48 less than z naught less than 1.26 is equal to 0.95. But z naught is 0.48 less than z naught, we know that 1 by 2 log of 1 plus rho by 1 minus rho base e, which is less than 1.26 is equal to 0.95. So z equal to 0.48. So 1 by 2 into log 1 plus 0.1 minus 0.48. So 1 plus rho by 1 minus rho, that is equal to cross multiply and taking the exponential form equal to 2.611 or rho is equal to 0.45. But z equal to 1.26. If that case 1 by 2 into log e 1 plus rho by 1 minus rho, that value is equal to 1.26. So to cross multiply and find the value of 1 plus rho by 1 minus rho, that is 12.43. Use calculator, or rho is equal to 0.85. Therefore the 95% confidence interval is 0.45, 0.85. So this one is cross multiply, and otherwise use calculator, directly we can get rho is equal to 0.85.